morning students, welcome to our video lecture. Jai Swaminarayan. Today we are going to conclude exercise 15.1. In the last lecture we did the sums involving mean deviation with respect to mean for group data, and all of you know that group data is divided into two parts: discrete frequency distribution and continuous frequency distribution. So that remains universal. Let us go down. Group data divided into two parts. One is discrete frequency distribution and the other is continuous frequency distribution. Our first two questions for the day, questions 7 and 8, are involving group data and discrete frequency distribution. A very interesting part, students. As far as discrete series or frequency distribution is considered, median n is equal to value of n plus 1 by 2th observation, and the formula to find mean deviation with respect to median will be sigma fi into mod xi minus n upon n, where n is equal to sigma fi. So students, in this type of sums, your basics of standard 8 and standard 9 comes into play. Your basics of students standard 8 and standard 9 comes into play. In some boards this is taught in 9th standard, in some boards this is taught in 8th standard, or even in 10th standard you are studying. Now questions 7 and 8 of exercise, question 7 and 8 of exercise 15.1, students, we are going to do. And do remember that median is called a positional average. So whenever we have to find median, whenever students we have to find median, the observations must be arranged in ascending order. So in the 7th, let us check exercise 15.1, answer 7. Observations xi are 5, 7, 9, 10, 12, 15, which are already arranged in ascending order. If not, then students, we have to arrange them in ascending order. Otherwise, students, we cannot do the sum. Means the method to do the sum, students, otherwise it will be definitely wrong. So we call this, students, we have to arrange the observation, students, in ascending order. Now students, all of you concentrate. This is going to be really easy once you understand, students. This is the possible easiest type of sums. Now students, what is the total of fi? 8 plus 6, 14 plus 4, 18 plus 2, 20 and 6, 26. So total of fi 26. Find CFI. 8 plus 6, 14 plus 2, 16 plus 2, 18 plus 2, 20 plus 6, 26. I hope all of you know, students, find CA5. Now, first criteria is to find median, and then only, students, we can make the columns of xi minus n and fi into mod xi minus n. So, median m is equal to value of n plus 1 by 2th observation. So n is 26 plus 1, 27 by 2th observation, which is nothing but 13.5. So what we have to do? We have to locate this 13.5 in the column of CA5. It is covered in 14 and corresponding xi becomes median. So median n is equal to 7. This is very interesting. Whatever value we get as value of n plus 1 by 2th observation, that we have to locate in the column of CA5, and corresponding xi will be median. So median is 7. Now make the columns of xi minus n and fi into xi minus n. So here I am writing mean deviation with respect to median will be sigma fi into mod xi minus n upon n. From every xi subtract 7, 5 minus 7 minus 2, and mod of minus 2 is 2. 7 minus 7 is 0, mod of 0 is 0. 9 minus 7 is 2, mod of 2 is 2. 10 minus 7 is 3, mod of 3 is 3. 12 minus 7 is 5, and mod of 5 is 5. 15 minus 7 is 8, and mod of 8 is 8. Now, students, the next column which we have to make is F5 into mod xi minus n. 8 2s are 16, 0 into 6 is 0, 2 2s are 4, 2 3s are 6, 5 2s are 10, and 6 8s are 48. This total comes out to be 84. So, students, finally, mean deviation with respect to median will be 84 divided by 26, and the answer comes out to be 3.23. This is, students, our final answer. So once again, students, this basic fundamental formulas will be same whenever you have to find median for a discrete series. This is also a discrete frequency distribution, students. It is also called discrete series. Then we have to use the formula median n is equal to value of n plus 1 by 2th observation. We have to use the formula median n is equal to value of n plus 1 by 2th observation. Okay, now let us do, students, sum number 8. This fundamental columns and layout will remain same. This is again a discrete frequency distribution. Now again xi are already arranged in ascending order, so that work is reduced here. Okay, xi are 15, 21, 27, 30 and 35. We never need the total of xi. Frequencies are 3, 5, 6, 7, 8. We will total it afterwards, so it is fine. CA5 3 plus 5 8 plus 6 14 plus 7 21 plus 8 29. So sigma F5 will be 29. Now, first of all, students, we have to operate median. First of all, students, we have to operate median. Median m is equal to value of n plus 1 by 2, 29 plus 130 by 2 with observation. So this will be value of 15th observation. This value we have to see in the column of CA5. It is covered in 21. Corresponding xi will be median. Therefore, median n is equal to 30 students. The observation corresponding to CA5 21 is 30. Therefore, median n is equal to students 30. Now operate the column of xi minus m and its mod. 15 minus 30 is minus 15. Its mod is 15. 21 minus 30 is minus 9. Mod is 9. 27 minus 30 is minus 3. Mod is 3. 30 minus 30 is 0. Its mod is 0. 35 minus 30 is 5. Its mod is 5. We don't total these columns as this total students are not required. Now, the next step, students, is to multiply 5 into mod xi minus m. 15 3s are 45, 9 5s are 45, 6 3s are 18, 0 and 8 5s are 40. Total this, if I total it, it is 148. So mean deviation with respect to median will be 148 divided by 29. So the final answer is 5.1. That's all, students. So now I suppose all of you have understood how to do the sums. Why we put similar type of sums together, students, so that you get a better idea of the concept. Now, students, the last two sums of the exercise remains, and for that you need to understand and refresh your basics of 9th and 10th standard. Okay, students, now concentrate. We are going for continuous frequency distribution and finding mean deviation with respect to median. Students, we are finding mean deviation, and that is with respect to median. Now, first of all, what is the formula for median for continuous frequency distribution? This I suppose all of you know. Median n is equal to L plus n by 2 minus Cm upon F into H or C. C is the class length, H is the class length. And mean deviation with respect to median will be sigma phi mod xi minus n upon n, where n is the total frequency. So now, students, we are going for some number. The last question was some number 11 and 12. 10 and 9 and 10 we done yesterday. So we are doing some number 11 and 12. Students, let us read the question here. We have to go at least find the mean deviation with respect to the median for the following frequency distribution. The data is regarding marks and number of girl students. Now, 11 sum. We start with classes and then F5 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. Corresponding frequencies are 6, 8, 14, 16, 4 and 2. Okay, students, here first of all we will find CFI to find median and then mean values XI. Now CFI 6 plus 8, 14 plus 14, 28 plus 16, 44 plus 4, 48 plus 2, 50. So this total comes out to be 50 students. Now, mid value I have taught you by finding mean deviation with respect to mid values I have taught by finding mean deviation with respect to mean. Mid value is the average of class limits 0 plus 10, 10 by 2, so 5. 10 plus 20, 30, 30 divided by 2, so 15, then 25, then 35, 45, and 55. Sorry students, why we need mid value? We need mid value itself because we have to operate mod xi minus n. And for continuous distribution, xi will be the mean values. Now median, first of all, these two columns are bending. Mod xi minus n and fi into mod xi minus n. First of all, we operate median. Now while finding median also we have to follow algorithm. Median n is equal to value of n by 12 observation. We call your 10 standard. Our first criteria is to locate median class. N is 50, so 50 by 2 will be 25th observation. CCFI 25 is covered in 28, corresponding class is 20 to 30. So median class is 20 to 30. So students, in this type of sums you have studied the basics in 10 standard. If you have forgotten, let us refresh your basics. So the first step is to find median class. The median class is decided. Now use the formula to find median, which is n is equal to L plus n by 2 minus CF upon F into H. L is the lower boundary point of median class, not limit. there is a significant difference between boundary points and limit. So this is lower boundary point, which is 20. N by 2 is 25. CF, we have to see of the above class. So this will be CF and this will be F. F is the frequency of medium class. H is the class length is gap between two mid values. So always remember, class length is the gap between two mid values. And this comes out to be, students, 27.86. This comes out to be 27.86. This is our median. Okay, now after finding median, we can find mean deviation with respect to median, which is sigma Fi into mod xi minus n upon n. Now from every mid value subtract 27.86. 5 minus 27.86 will be minus 22.86. So its mod is 22.86. Then go on, you can say reducing by 10 because the gap between mid values 10. So this will be 12.86 and this will be 2.86. Now it will change. 35 minus 27.86, so this will be 7.14. Go on adding 10, so this will be 17.14 and this will be 27.14. You have to use your simple calculator. Multiply Fi into mod xi minus n. 6 into 22.86, 137.16. 8 into 12.86 will be 102.88. 102.88. 14 into 2.86, 40.04. 16 into 17.14, 114.24. This we have to calculate before it. 4 into 17.14, 68.56. And this is 54.28. Total of this comes out to be 517.16. 517.16. So this will be finally 517.16 divided by 50. So it's the final answer comes out to 10.4. So mean deviation with respect to median, students, comes out to be 10.34. So this sums are very lengthy because first we have to find median. After finding median only, students, we can find mean deviation with respect to median. Now let us do the last sum to complete the exercise, students. Let us do sum number 12. This formulas and layout will remain same. So I'm not erasing the layout. Now sum number 12. We are given a frequency distribution of age of 100 persons. Find mean deviation with respect to median. Let us note down the classes, students. The classes are 16 to 20, 21 to 25, 26 to 30, 31 to 35, 36 to 40, 41 to 45, 46 to 50, and 51 to 55. Corresponding frequencies are 5, 6, 12, 14, 26, 12, 16, and 9. Total is already given in the question only. Number of persons are 100. Now, students, let us operate CA5. 5 plus 6, 11, plus 12, 23, plus 14, 37, plus 26, 63, plus 12, 75, plus 16, 91, plus 9, 100. Mid values: 16 plus 20, 36 by 2, so 18. Here 23, 46 by 2. Add 5, then again 28, 33, 38, 43, 45, and 48 and 53. This is also very simple. Now, students, there is a gap between upper limit of a class and lower limit of next class. This gap is 1. So this distribution is called inclusive. What type of distribution? Inclusive. And to find boundary points, the half the gap between 20 and 21 is 1. Half the gap is subtracted from lower limit. So the boundary points will be 16 minus 0.5, 15.5. And here 20 plus 0.5 will be 20.5. Whenever there is a gap between upper limit of a class and lower limit of next class, such a frequency distribution is called inclusive. So for median class, we need boundary points. Value of n by 2, 100 by 2 is the 50th observation. In CA5, 50 is covered in 63, so median class is 36 to 40. But boundary points are 35.5 to 40.5. We have to write boundary points whenever the distribution is inclusive. Whenever there is a gap between upper limit and lower limit of next class, this distribution is called inclusive. In inclusive, class limits and boundary points are not same. So this is altogether a different concept of statistics which we have to remember. Now L is the lower boundary point of median class, so 35.5. N by 2 is 50. CF of the above class is 37. Frequency of median class is 26, and class length will be definitely 5. 37 frequency is 26, and H means class length, which is 5. So 13, this is 13, so 5 by 2, so it will be 38. 5 by 2 is 2.5. So median is 38. Students, median is 38. So something new we are studying. Whenever there is a gap between upper limit and lower limit of succeeding class, such a frequency distribution is called inclusive, and for inclusive we have to write boundary points. For finding boundary points, half the gap is 1, half the gap is 0.5. Subtract 0.5 from lower limit to get lower boundary point, and add 0.5 to upper limit to get upper boundary point. Now 18 minus 38 minus 20 mod is 20. Then reduce by 5. So this will be 15, 10, 5, 0, 5, 10, and 15. Then 25 is 100, 15 6 90, 120, 14 5 is 70, 0, 12 is a 60. 16 10s are 160. 15 9s are 135. And this total comes out to be 735. So mean deviation with respect to median is 735 upon 100. So the answer is 7.35 years. This age is also in years because the data is given for age. So students, in continuous frequency distribution also we have two types of distribution. One is inclusive and other is exclusive. You check in the classes of, students in the classes of 11th, the limits did not have any gap. The first class is 0 to 10, second class was 10 to 20. There is no gap between upper limit of a class and lower limit of next class. Such a frequency distribution is called exclusive. And whenever there is a gap like this, such a frequency distribution is called inclusive. So for inclusive, we have to find boundary points. For exclusive, boundary points and class limits are same. I am not going into much details, but it is quite interesting for you to know that in continuous frequency distribution, again we have two types. One is inclusive, the other is exclusive. The example of inclusive is sum number 12, where the gap is there between upper limit of a class and lower limit of next class. For exclusive students, there is no gap between upper limit of a class and lower limit of next class. So I think students, we conclude the chapter, we conclude the exercise. We conclude the first part of the chapter, I mean to say. We conclude the exercise. Your prime work is to do this sums twice. Note down this result that in continuous frequency distribution, we have two types of distribution. One is inclusive and other is exclusive. Example of inclusive classes is sum number 12 and examples of exclusive classes is sum number 11. Remember this, for inclusive classes, whenever we are finding median for inclusive classes, we have to find boundary point of only median class. We have to find boundary point of only median class. Thank you, students.